Just like
Next
first
one.
name,
I
dot
didn't
last
even
name.
have all the numbers behind
It
it.
is saying that the length of life in years T of a heavily used terminal in a student computer lab is exponentially distributed with lambda equals to 0.5 years. So, first start writing that distribution. Okay. So, what's the failure rate? Yeah. What is the reliability function? It's 1 minus it's gonna be and what is the probability of this item last more than 1 year? So we're gonna insert 1 year as the small t there, and it's gonna be e to the minus 1, which is 60. So the probability that terminal will last more than 1 year would be 60%. And if you wanted to do that in R, you can write 1 minus p of exponential. Then insert 1 as 1 year and the lambda. Suppose that there are 100 terminals in the lab. How long will it take to have 90 of them still working or 10% of them broken down? We just wanted to write it as the formulas. So it's going to be P of t greater than something we don't know because we don't know how long it will last is equal to 90%, or the probability that the age of that one is less than that number is 10%. Or here we make the assumption that that k is 3 months or 0.21 years. And then your prediction would be after just under 3 months, 10 of those terminals are going to be expired or they're not going to work properly. Is that clear? Studies of the single machine tool system showed that the time the machine operates before breaking down is exponentially distributed with a mean 10 hours. So, determine a failure rate and the reliability. Alright. So, how can we calculate the failure rate? Here it's saying that the mean of breaking down is 10 hours, right? And we are looking for the rate, right? As I told you, this is showing the Poisson distribution because it's showing the occurrence of that, the duration of the time that it takes to have that fault. Yeah. So the expected value of having a trouble here is 10 hours. and the rate would be the reciprocal. So, next question would be find the probability that the machine operates for at least 12 hours before breaking down. First, how should we formulate that? Probability that the machine operates at least 12 hours. Greater than, because it's saying at least 12 hours. And here we can 1 minus 0 to 12, and we can write the distribution. Lambda 0.1
That's also in the sequence.
Yeah, because it's showing the time between having some failures, and if we want to calculate the rate of having those, we're gonna get the reciprocal.
The book said, rotate. Take that tab low and rotate it down and read.
If the machine has already been operating 8 hours, what is the probability that it will last for another 4 hours? That's a tricky question.
Imagine you have a problem with that.
What did we say before? We said that it's memoryless, right? So it doesn't have any effect for it. So 4 more hours, it's
That's why you do it.
similar
These
to,
kind of things, you don't need to cover. It's good to hear the word, but this is the expert.
Conditional.
This kind of problem, you better solve by the Google.
and we can get the result.
Be aware. that-
Everyone got that?
And then there are other companies. One of the ones we talked about is security.
Okay.
Remember
So,
our.
we are kind of done with exponential distribution, but Dr. Sani told me to show you one case study, one real case study that was done. It's like a paper, and I will ask the TA to post it for you. You can read it yourself as well, but we can go through the introduction, and it's saying that in the lean systems, also the reliability is important, and all this stuff that Dr. Sani is talking about. So do you have any question before we move to that part from all the calculations and the exponential distribution? You're good?
No, I do.
You have? Okay, go ahead.
On those example 5, the last one,
Uh-huh.
for what you have on the board compared to e to the negative 1.2, did that just, that one, so 1 minus
Yeah.
0.1 e, or, I mean, 1 minus that integral, is that the same as the e to the negative 1.2?
Yeah, yeah.
It multiplies the 0.1 by the 12 to get that negative 1.2. Because it's 12 hours. When you finish that integral, you get plus
Yeah.
minus 0.
So here we're gonna
0.1 times
have this
12.
0 if we insert that.
Uh-huh. So you take the 12 minus 0.1.
These are more complex. Something you get in your second option, which is ample language and all about the different rules and standards for a mathematical.
You're right.
Anybody can do something. What did you hear? Right, so
There's
here's the
something
paper,
wrong there.
reference on it, it's Bell Labs.
You have this one.
1985. Here's just a sample of what it looks like. And so you can see when you look,
0.9
if you zoom in here, you've got your parameters you set, you've got your variable, you've got an objective function, you've got your state. We'll look at the math. This little thing I had was some
Yeah.
statistics from
We
our
have to
financial
fix
lab. They have an optimization server that they user centers that fits the use. These are the statistics
Any more questions?
on the languages that people have used, and look, the one that's used the most is the AMP, so we have something to learn.
Is it it's negative 0.1 times 12, right? And then exponential?
Yeah.
Okay.
So when you look at these programming languages, some of the features of language, you'll be able to build your system in it, like I said.
Any more questions?
That sort of thing, in your language, and you'll see. And then, one of the characteristics they have is the ability to look in different solves. But like I say, different problems are solved in by different solves. I mean, like the linear problems, okay, nonlinear problems, whatever. That's one of the characteristics, and then the ability to look into different things. Post-processing, MATLAB has a toolbar, optimization toolbar. You know how MATLAB works. Validation, what's it
Can you
called?
read it?
Validation, what's something else?
No.
I have to have it at home. I can play it, that's why I'm not
So I can read it loud. Increasingly, managers and engineers who are responsible for manufacturing and other industrial pursuits are incorporating a reliability focus into their strategic and tactical plans and initiatives. That's exactly what Dr. Sani is telling you, right? He's saying that if you're implementing lean in your system, you have to take into account this reliability, because you're simply reducing every single part, every single excessive part of your system without just making sure that your reliability of the system is going to remain the same. It's not a correct thing to do. So every time you have to be careful about your reliability. This trend is affecting numerous functional areas, including machine system design and procurement, plant operations, and plant maintenance. With its origin in the aviation industry, reliability engineering as a discipline has historically been focused primarily on assuring product reliability. Okay, so all the time, all the terms of the reliability that we heard till now is on maintenance of the machine. Nobody is saying that we have to make sure that people are working reliably in our system. Schedule should be reliable in the system. So we have to kind of apply it to every single part of your system. More and more these methods are being employed to assure production reliability of manufacturing plants and equipment, often as an enabler to lean manufacturing. This article provides an introduction to the most relevant and practical of these methods for plant reliability engineering, such as the calculation of the failure rates in PDF, availability, and introduction to exponential distribution is exactly what we did here. Identifying failure time dependencies using the versatile variable distribution that he is going to cover it in the next session probably. Developing an effective field data collection system. I'm going to just go through the introduction for you, and you can just read all the rest yourself. The origin of the field of reliability engineering, at least demand for it, can be traced back to the point at which man began to depend upon machines for reliability. We know that because from very initial point of humans, they were, for example, building some machines to pump the water. And if something went wrong with that machine, then everybody's life was dependent on that. And that's the point that reliability is very important for us. I'm just going to take your attention to the parts that have saying that, for example, time is very important. People are very important in the system. And if you go and skip this paper very fast, you can really see what Dr. Sani's goal of teaching this course is. He is trying to teach you that besides the initiatives of lean, other things such as reliability, such as time, are really important in your system. If you want to implement reliability in your system, you have to just identify what's going on inside your system, what kind of data you need to calculate the reliabilities, and then apply all of these rules or, formulations there. So that really depends, and we cannot say that, okay, if this was the exponential distributions that we went through today, it could be applied to every system that you are working on. So it really depends on what you are doing, if your system is repetitive or if not. For example, if it's not repetitive, then what kind of distribution could you fit to your model or your data collection? And first of all, how could you collect that data? If you read that paper, it will give you some more general ideas. And if you had any questions, probably next session you can ask Dr. Sani, because he's explaining way better than me. I'm gonna ask her to post this one for you if she hasn't. Okay. Yes.
So if we're not given the right reliability, then we calculate according to the probability you gave the whole purpose
And so the way you do the math here.
of the lecture today. Because he talked about last week that if you're not given the reliability, then he's going to show us how to do that.
Yeah, because I think that he meant that number that they gave you. For example, for trimming, the reliability is 0.9. How do you know that it's gonna stay 0.9 for all the time? And that's the reason for studying all the distributions over time. Did I answer your question? Or I think that we wanted to remove these assumptions that you had till now, which was assuming reliability as a single value.
Oh, this is over time.
Yeah.
That's virtual time.
Oh, but it's still okay, yeah.
So,
And you do that,
okay.
you can see how it grows. So, but you can also see how if you don't understand.
Any more questions?
The size is, how to write things, like the first time I did it in MATLAB, I wasn't thinking, I got the.
If you don't have, we can call it a day. Because
Because
I was told that I can finish at 1. You're finishing it 5 minutes earlier.
We'll round up.
Oh, really?
So we're.
Oh,
The point is not to make you mad. If you're going to program what it's for, how